and welcome to game day at Rapid Plus TCT 2022. I'm here with Justin Michaud of REM Surface Engineering, and just wanted to catch up. You know, we've got to see each other a little bit over the last, I guess, year. We finally started to get back together, but fantastic to be here in person, again.
Yeah, absolutely. Excited to get back to these face-to-face events, and get to see the great team here at America Makes, and get back here at Rapid.
So I haven't got to come down to your booth yet, but maybe you could talk just a little bit about what's going on. What's I don't want to ask what's gone on in the last couple of years because the COVID. But how have you seen folks get more interested in what you're doing, or maybe what better question? What question are you getting most right now from a potential customer?
I don't know that we're getting any one question specifically. I think we get a lot of questions about looking to solve, I don't want to say problems, but maybe just deficiencies in some of the as-printed state of parts, right? A lot of parts, they're ready to go maybe right off the printer, but a lot of them need something more. And that's where someone like us might come into play, a surface finishing company, providing solutions to different sorts of applications. So it's really all about kind of finding the right parts and the right applications. Yeah,
so maybe you could just talk a little bit about surface engineering and what part, where that fits into the AM value chain as a whole. There are not many situations where we're producing a part, hitting print, and then putting said part on a vehicle, aircraft, etc. It needs some kind of further preparation, other additional steps in the value chain. Where does REM fit into that value chain?
It's a good question. So obviously there's more than just us and surface finishing providers, right? And you got to have lots of tools in the toolbox. For us, really, typically you're looking for us if you need some sort of an engineering solution, right? Like we can give you bright, shiny, pretty surfaces, right? Like that's nice. But that's not normally why you're coming to us. That's kind of a byproduct, right? So we sort of first made our name with fatigue, right? We were able to reduce, fatigue deficits, increase high cycle fatigue life of AM parts, get them to meet, machine components, which not a lot of people were able to do. And then kind of going beyond that pushed us into the more challenging applications. So space, aerospace. AM's been great for that. It's made a lot of new entry points for us, new industries. We were not working in space significantly 5 years ago, right? Now we've got tied in with NASA and commercial space, thanks to some nice cyber work, and so we open up some opportunities for us to expand our capabilities. So things like looking at finishing of internal cooling channels, right? To get rid of loose powder, reduce pressure drop. It's something that's new for us in the last 3 years, but it's becoming a big part of our business. And that's the cool thing about AM, is it really opens up these new avenues.
Yeah, and I think, something that's really important is, folks who are leaning in like your organization, trying to figure this out, but then once you and the others in the, kind of your competitors in the space are developing solutions, I think the next challenge is about getting those into the hands of people, we've been talking a lot, it seems like, over this last, year and beyond about the supply chain, but I think there's a little different way to think about this, and be interested in your take on this, is as you develop a solution, how are you seeing that technology be adopted or transitioned? How do you get the word out to folks who, is it people coming to you, or are you pushing the technology out to the community?
Yeah, so we're fortunate in that, we've developed at least a little bit of a reputation in the AM space that we do have pretty steady inbound, people coming to us, they know that we can solve a number of different challenges and problems. But we are also trying to push it, because there's different applications, different reasons to look at us, and it's still a maturing industry. A lot of people, you have the folks who are still coming with just like, I've got a print and it says, this is your RA, can you hit this? And that's okay, right? That's a part of the business. Yeah. But we're also seeing the move away from that, where it's more about performance driven, right? Like what do we actually need this part to do? What surface do we need? Because not all surfaces are the same, right? You can have a number that's the same, but it can have a different performance factor. So these are all things that need to be kind of considered.
So, the engineering portion of your name, admittedly I don't know this, so maybe it's a blind question, but everything you just kind of walk through, it makes sense and I understand. Are you seeing the, I'll call them tech warrant holders and folks who are kind of in the engineering side of the business, who are trying to push the boundaries of what they're capable to do, capable of today? Are you interacting with those folks to help it? You know, like you said, it's great to say, hit RA 125 on this. You know, we know how, we'll follow this recipe, and we can do it. Are you seeing much traction with kind of the engineering side of the community who are reaching out and actually working with you to develop solutions to, you know, they don't know what they need to hit other than they need a capability that we don't have today?
We are. I think it's still the minority, you know, because not as many people are going and pushing in that path. It's a harder implementation. If you can hit a print spec and call it like for like, that's an easier path. But no, we are seeing that. It comes back to, you know, finding the right parts for AM. You know, so I'll hit on like rocket engine applications, right? I mean, they are the incumbent manufacturing technologies for that were very timely and very costly. So there is a very good value proposition there, and those folks as such, they've got funding to look after these things and figure out what they actually need, and they're not just saying it's just hit this or just do that. So we are having those conversations, and more we are having those good intro discussions before parts are even printed. So we're talking about material offsets, we're talking about what you need, we're talking about subsurface porosity. Is it there? Have you looked at it? You know, what do we need to deal with that now? And because it's in the early days, you got a lot of parts, and you'd get, hey, yeah, can you take off, you know, less than 1 micron and give me a perfect fit? No, we can't. That's not us. Maybe somebody else can. But no, those conversations are going, and it is encouraging to see. And I think that's really where we're going to unlock the real capability of AM.
Is that kind of the direction that you see the, you know, for example, the SIBR work that you referenced? Is that where you're seeing folks start to kind of at least explore what is possible?
We are. So yes, we've got a pretty defined split in the SIBRs that we're doing. I think half of them are that, where it's looking at new applications, looking at, like, you know, how do we use this AM technology the right way to maximize it and get these parts that we couldn't otherwise produce, or make it more efficiently. The other half of it, which is also a good one, is we're seeing a lot of sustainment, right? I mean, there's a need for it. There's a lot of these long lead time parts, and even though it's not maybe as, you know, sexy as some of the rocket engine stuff, you need brackets, you need these components, you need bell cranks to keep these airframes in the air, you know, get them back out there, and that's kind of the other side of what we're doing. And there's still interesting things we can do there, right? Because additive is cool and it's amazing, but you still have things like support structures, right? And like, if you've ever seen people take those off, it's not the process that you think it is, right? It's a lot of like chisels and wrenches and whatnot. So we've got some interesting programs there where we're looking at, you know, utilizing our process to take that off, you know, hands-free, which hopefully then is just going to open up more opportunities. And then once you get, I think, that groundwork in for those sustainment applications, that's when we can start looking to push beyond that and say, how do we not just sustain, how do we upgrade?
Yeah, I think that's an interesting point. As someone who doesn't do it every day or really ever, to then see the true manufacturing realities of what goes on to get to the end state that is, you know, our acceptable state, which is good. There's a lot of opportunity in between that I think we're all excited to be working on together. So
definitely
appreciate your time today, sir. Hope you have a fantastic show. Thanks for having a chat.
Thanks for having me. Always good working with the folks here at America Makes.
Thanks.